I use this if I can get people move over to this side, and then I'll just talk from the floor. Little less light, perhaps up above. I hope I can provide that light with some of the information. I appreciated Dr. Clapperton's presentation. That's been an area that I've worked in for 55 years. And you see the tremendous dynamics in those interactions, especially in your operations. But if you'd like to stop me and ask questions anytime, you're more than welcome to do that. Pull the shirt tail. Tend to get off on tangents. So, but I wanted to discuss some things that would be of interest to you. Now, I've prepared mostly relative to the glyphosate and GMO interactions spent 20 years research on how do we remediate this process that we've gotten ourselves into, as well as how do we understand what's going on. And you have to realize, especially that in farming, we're really farming or we're managing an ecology. And that's what Dr. Clapperton presented. A lot of people forget that, but you also have to realize that everything that we do changes the interaction of those four components. Now, for my career working on soil-borne diseases, that was the key to understanding how to get disease control, because we didn't have chemicals, we didn't have good genetic resistance to most of these organisms. We had some resistance, but we could always enhance that resistance if we looked at the nutrient interactions so that we could get those mechanisms functional in the plant. So, if you looked at the keys that we use for controlling soil-borne diseases in general, you see those 6 keys: the rate, the form, the timing, and the interactions between your different nutrients. And you see how that all comes together to give fairly effective disease control, as I mentioned yesterday. What we found recently is a lot of those old management tools aren't working for us. And it's because we had a change, and that change we call glyphosate, a very powerful chelator, or the genetically engineered crops that tolerate it and move it throughout the root system, both in the weeds as well as the genetically engineered crops, to completely change that interaction of the plant, the abiotic environment, the soil biology, and then the relationship to the pest. So that as we've seen the continued use or abuse of glyphosate, we see that there's been a very dynamic change in our disease pressures. I mentioned we have over 40 diseases that used to be fairly effectively controlled that are now essentially out of control again for us. We have growers in the States, in Kansas, as well as in Canada, that have commented they no longer grow wheat and barley economically. We have the lentil and pea industry from the Pacific Northwest moving over into Montana, where they haven't had as high glyphosate usage. And it's just a matter of time, unless they start listening to Dr. Clapperton, until they'll be in the same point of no longer being able to produce an economic crop, where at one point in time, that area in the Pacific Northwest used to be essentially the world's capital for pea and lentil production. The reason is they can't get inoculation. They can't maintain that source of free nitrogen that should be providing least 2/3 to 3/4 of all the nitrogen needed by a legume crop, and then leave a residual nitrogen for a subsequent crop in the rotation. But it does much more than that. Had the privilege of being involved in projects in developing desert lands, bringing them under cultivation in Idaho, Oregon project in the late 50s. Also in Brazil and the China project, 3 million acres brought under irrigation for the first time. And you realize the importance of that biological buffering capacity in the soil. If we don't do it in the first 3 to 5 years in those new soils coming under cultivation, we lose an opportunity that then we have to fight these diseases and manage them much more differently than if we'll establish that first biological buffering in the soil that gives us a leg up on the control and on the management then for the next 2,000 years. In China, we have plots and projects that are 40 miles apart, where we have almost zero take-all from an economic standpoint, extremely high yields on those very fertile irrigated soils that we're running as much as 250 meters of topsoil because half of Europe's topsoil is blown over on the Gobi Desert in those areas. So that very productive and 40 miles away, you have a 50% loss from those diseases in spite of the best management that they can economically afford. They're limited in what they can do compared to what you and we can do in the States. Where's that management? So you realize how important that management aspect of this ecology becomes. When we use crop rotation, we're doing that to manage nutrition more than any other thing, because it's that management of nutrition, that change in the soil microflora, that determines what our disease response is going to be. The immediate crop preceding in the rotation is going to have 85% of the effect from a disease response. The long-term effect, as far as disease control, is effective for nematodes or some of the invasive type of diseases, pathogens, but not for those indigenous soil-borne organisms like Rhizoctonium, Pythium, Phytophthora, and all of those organisms that are essentially indigenous organisms in the soil. What we have to do with those organisms then is we change the interaction of microorganisms that interact with those pathogens, not necessarily changing the population of the pathogen. For years we said, well, we're reducing the population of fusarium, and that's why we have disease control. We're reducing the population of Gomomyces for take-all. When you go into the soil with a micromanipulator and you pull out those actual mycelia of those pathogens, and especially if you have techniques that we use now for studying the active growth of those pathogens, rather than just their spore populations that are present or absence in the soil, we find that there's almost no change in actual population when we have very severe disease and almost no disease. You see that with your fusarium head blight. The fusarium's there all the time. Now it's not on not infecting the head when you don't have head blight, because the physiology of the plants changed. But that's because of the resistance mechanism, again, a nutrient-driven response. We can change that nutrition very well and still maintain our overall fertility for the crop. Again, we can do that by the rate of the nutrient, by the form of the nutrient, or by the tillage to make some of those changes, get some aeration. Time of tillage becomes very important. Fall tillage for our areas, for your area, will have a much different effect than a spring tillage. We had our IPM plot at Purdue University, Michigan State, had the opportunity to work at the Purdue farm, a 40-year IPM plot where they had very stable rotations that had been maintained all that time. So we could go back and look then at those changes with crop sequence, with overall crop rotation, and then understand a little more about those ecological interactions that become important for disease control. Felt like I had a very good understanding of what those relationships were for a number of diseases, for the fusarium diseases, for rhizoctonia, for gonadomyces, for take-all, for a lot of those diseases, and all of a sudden we saw that whole base of understanding change. We would do the same things and our disease response was very different. And that change was essentially this broad spectrum, very powerful herbicide that we were starting to use everywhere. And trying to understand what those changes were then brought me back to having to look at what's the mechanism, how does that herbicide work. I've been involved with a number of other herbicides and registration processes, very familiar with the chelation process, and started checking, sure enough, glyphosate was patented as a very potent chelator and a mobilizer of nutrients 10 years before it was ever patented as an herbicide. Started kind of turning some light bulbs on, or at least setting up some flags. Well, maybe you ought to look here. Maybe it's not that there's a new mechanism that's involved in this increased disease we're seeing, but maybe it's just a matter of understanding of what the ramifications of this extensively used chemical are. How it impacts then our overall crop sequence, crop rotation scheme. I was called out to asked to look at a field of potatoes 2 years ago. I head of the Idaho Potato Commission, Mark Cohen. He said, I can't understand it. He said, I've looked at, I've grown potatoes for 30 years. I've always had very little verticillium wilt. When I've used corn as the preceding crop to my potato. That's the standard crop sequence for most of our potato producers. You'll find the same thing, same interactions on Prince Edward Island. They see the same relationship. If you look at our data from the from the Purdue IPM plots, those 25-year plots where we've had corn, wheat, and soybeans in all sequences of rotation for 25 years, and you start looking at the soil biology, you find that corn will leave twice as much manganese available for the subsequent crop as wheat or soybeans will. Found it for 25 years. When we substituted Roundup Ready corn,